In the following video, we will see how to implement a pick-and-place application. This application will make use of all the previous functions that have been implemented. That includes all the inverse kinematics and the linear movements. This is the code for the pick-and-place application. Everything is almost the same as with the linear movements. I mean, all the functions that have already been implemented are included here too. But now we have something new. For example, here we have defined the angle at which the gripper must close to hold the desired object. And in the functions, we have some new functions. These are all the same that have already been explained. And in the end, we find 4 new functions. The first one is open gripper, which is just writing in the servo of the gripper, which is this one that has been defined as a servo, and it writes this angle, which is the angle that has been estimated to open the gripper widely. The same logic has been followed in hold gripper, in which the angle that is passed is the one that we have seen before that has been estimated for taking the object properly. The third one is close gripper, which just passes the value 90 degrees to the gripper so that it is completely closed. The last one is the most important function of the new ones, which is the offset. With this, what we are doing is passing a position, which is called target here, and giving 3 new values. These 3 new values are added to X, Y, and Z of the position. This is very useful in pick-and-place applications because we want to create a stopping point. For example, we want to stop maybe 3 centimeters before the object so that the gripper can open without hitting the object. In this way, we don't have to put a lot of points at the beginning of the code, which will be more difficult to calculate. So, as you can see here, we only have defined 3 points. The first one is the initial position of the robot, where all the joints are 90. The second one is the point of where the object will be grabbed, and the third point is where the object will be left. So, in the setup, now we have to put the sequence of operations. This sequence starts by putting all the servos at 90 degrees, and afterwards, with move J, the robot will move to a position close to the object. As you can see here, it is a position close to the first point where the object is grabbed, but with an offset in X and in Y. And as you can see, we have chosen to put move J because we don't care about the trajectory that the robot follows, since it is not holding anything. But later on, we will see that all the movements must be linear so that the object doesn't shake. When we are close to the object, we have to open the gripper. And now, with the gripper open, what we have to do is approach to the point where the object is left. Now we don't have any offset, so it is the exact point. There, what we have to do is close the gripper to the angle to hold the object. And now that the object should be held, what we have to do is move a little bit farther from the position where it has been picked. So if, for example, one object is attached to any type of hook, the first thing that should be done is moving the object apart from this hook. This is not the case, but what would usually happen in other applications is that we need an offset to elevate maybe the object. So this is what has been simulated here. Point 1, where the object is picked, with an offset of 50 in the Z axis. That means elevating the object a little bit. Now, what we have to do is move to the position where the object must be left. But again, for safety reasons, it is better to move to a position that is not the exact point, but instead to have a little bit of offset, which is what is implemented here, in which we have offset in X, Y, and Z. We have chosen to put move L because if the object was something that we cannot shake, maybe it is more convenient to follow a rectilinear trajectory. But if the object is not something really fragile, we could have used move J. For this case, it wouldn't matter since the object is not fragile at all. So instead of move L, we could put move J and it shouldn't matter. But this is just a decision. So now that we are near to the new point, we are getting closer in X and in Y, but we are still having some offset in Z, so that the object is elevated with respect to the final position. And finally, with a rectilinear movement, the object is finally left at the exact point. There, the gripper shall open, so it releases the object. And now, again, for safety reasons, it is better to move carefully the gripper farther from the object so that it doesn't hit anything. And for this, we have implemented again an offset in X and in Y, and then an offset in X, Y, and Z. And in that point, which is close to the point where it was left but far from the object, the gripper can close safely. From that position, it must go back to the initial position, and again, since we are not holding any object now, we can use move J because we don't care about the trajectory of the robot. And again, finally, all the servos are detached. Now we will see this in the simulation. Now we will see how the pick and place application behaves in the simulation. So let's start. First of all, the robot must move close to the object, but with an offset. It opens, moves closer to the object, and grabs it. Now it elevates it and moves near to the position where it will be left, but again with some offsets so that the movements are really safe. It leaves the object, and now it gets farther from it, closes, and goes back to the initial position. Now, in order to check that the movements that are more difficult, that means the ones with the object being held, are rectilinear. So let's repeat it. First of all, this is something that is not really important. The trajectory is not really important because the object is not held, but now all movements are rectilinear, as you will see. This is rectilinear too. Now it goes downwards in a straight line, leaves the object, and is still moving in straight lines. But now it will move as it wants. Okay, this is the scenario for the pick and place application. The robot must pick this object and leave it up there. So let's see how it behaves. It must start with a move J, that means that the trajectory is not important, but when it holds the object, all the movements must be linear. This is move J, but now it's the linear movement. It grabs the object, lifts it, and now with linear movements, it must leave it in the correct position. With linear movements, it goes back, and now back to the initial position. In this video, we have shown how to implement a pick and place application in the robot, and we have also seen a demonstration in the simulation and in the physical robot.